This is part 8 of the Module 6 lecture. In this last section, we're going to learn to use the normal distribution to approximate binomial probabilities. So the general procedure that we're going to follow to do this is, number one, you need to ensure that the problem you're dealing with corresponds to a binomial experiment. And then identify what is the binomial random variable and what are the number of successes involved in the probability question. Once you do that, then you need to ensure that a normal approximation can be used. That means that you need to find the n, or the number of trials times the probability of success, is at least 5, and the number of trials times the probability of failure is at least 5. If these two conditions are met, that means that you can use a normal distribution to approximate the binomial probabilities. Once you've done that, then you can determine the mean and the standard deviations for the normal distribution that we're going to use to do the approximations. And then you determine the normal probability to obtain by adding or subtracting the continuity correction factor to the number of successes that is the element of the probability question. And then once you find that probability statement, then you can go to table 4 and find the corresponding probability. And once you have the probability, well, the last step is to interpret that value. All right, let's see how we can apply this procedure to solve problems. All right, in this first example, we have 51% of adults in the US whose New Year's resolution was to exercise more achieve the resolution. So in this particular example, 30 adults in the US whose resolution was to exercise more were randomly selected, and each asked if the resolution was achieved. So the question is, what is the probability that 40% of these 30 people achieved the resolution? All right, well, let's follow our procedure and see how to solve this problem. So number one, we need to verify that in fact what this problem is describing a binomial experiment. So we can see that there were, or at least imagine that 13 individuals were identically interviewed. So we could say that yes, we have 30 identical trials. And there are only two possible outcomes. Either they met the resolution or they did not. So there is only two answers. The probability of answering yes, I met my resolution, is the same for every person interviewed. And that probability is 0.51. And the interviews are conducted independently. Again, that's an assumption. They don't say that, but we can imagine that these were conducted independently. We can make that assumption. And then the random variable counts the number of positive answers, and these go from 0 all the way to 30. So we can say that this problem description corresponds to a binomial experiment. So we could use the binomial formula to calculate the probability that there are 12 successes, or 12 of the 30 individuals answer yes. And I said 12 because there are 30 people interviewed, and we're looking at 40% of them met their New Year's resolution. So the x sub 0 is 12, the value of the random variable, of the binomial random variable, that is. All right, next step, we need to verify that the normal approximation can be used. And you can see that multiply the number of trials times the probability of success, that's 15.3. And the number of trials times the probability of failure, that's 14.7. Both larger than 5. So yes, we can use a normal distribution to approximate the binomial probability for this problem. Then, which normal distribution are we going to use? Well, the one with this mean and the one with this standard deviation. So the mean is going to be use the number of trials times the probability of success, that's 15.3, and the standard deviation is the square root of the product of number of trials, the probability of success, and the probability of failure, and that's 2.738. So now in step 4, we need to figure out how we're going to use the continuity correction factor Now in here, we are looking at probability of exactly 12 successes. So to approximate the probability that we have exactly 12 successes, we need to do that with the normal probability distribution that the random variable is between 11.5 and 12.5. So the next step is that now that we established the probability statement for the normal random variable is to find the z-scores for the y values that limit the normal random variable. So z1 is 11.5, the lower limit, minus the mean that we determined here, and divided by the standard deviation that we already determined. So we find the z-value, that's minus 1.39. So that upper limit, 12.5, we transform it into a z-score following the same formula, and we find that that's minus 1.02. All right. So now, then using these z-values, we go into table 4, and we find the probability that the standard normal random variable z is less than 1.39 is 0.0828. You find this in table 4. And the probability that z is less than minus 1.02 is 0.1539. Again, you find this in table 4. Now, the probability of exactly 12 successes is approximately equal to the probability that the normal random variable is between 11.5 and 12.5, or that the standard normal random variable is between minus 1.39 and minus 1.02. And if you remember, we calculate the probabilities and we subtract the smaller probability from the larger probability. And then we find that the approximate probability of 12 successes is 0.0716. So once you find the probability that you're looking for, then you interpret that probability. So in here we said that the probability that 40% of the 30 people interviewed achieve the resolution is approximately 7.2%, or 0.0716. Now, if you calculate the exact binomial probability using the binomial probability formula, you find 0.07101, which is relatively close to the approximate probability that we found with a normal distribution. All right, let's look at another example. So in this example, a survey reports that 86% of internet users use the Google Chrome as their browser. So researchers selected 200 internet users at random and asked each of them whether they use Chrome or not as their browser. And the question is this a binomial experiment? Can the normal distribution be used to approximate the binomial distribution? And finally, then what is the probability that 176 or less internet users use the Chrome browser? You can see that if you look at this number, you have 176 calculations with a binomial formula. So that's not going to be easy to do. So here's where the normal approximation is very useful. All right, let's see if we have a binomial experiment. So there are 200 individuals that were identically interviewed. So we can claim that we have 200 identical interviews and that only 2 answers for each interview. Yes, they use Chrome. No, they don't use Chrome as their browser. And the probability of answering yes or no is the same for every person that was interviewed. And the problem doesn't say it, but we can assume that these interviews were conducted independently of each other. So the answer of one person does not influence the answer of another person. And the random variable x counts the number of positive answers from 0 all the way to 200. All right, so I think we can say that yes, we do have a binomial experiment. The next part says, well, can we use a normal approximation? Well, then we verify the 2 conditions. When we multiply the number of trials times the probability of success, and that's 172. and the number of trials times the probability of failure is 28, clearly both larger than 5. So yes, we can use the normal approximation. So the normal distribution to use is a normal distribution with a mean of 172 and a standard deviation of 4.91, calculated in this way. All right. So now, once we have that, we need to figure out how to add the continuity correction to find the correct probability statement in terms of the normal random variable. So the probability in the binomial random variable is that is less than 176 or less. Because it's a probability to the left, then we add the continuity correction factor to that number. So the approximate normal probability will be that the normal random variable is less than 176.5. So once you have found that, then we calculate the z-score for 176.5 using the mean and the standard deviation that we calculated in step 3, and that gives you a z-value of 0.92. So if you go into table 4, you find then that the probability for this z-value is 0.8212. And so we can say that the probability of obtaining 176 or less successes is approximately equal that the random variable is, or the normal random variable is less than 176.5, and that is equal to the probability that the standard normal random variable is less than 0.92. So once we have the probability, we need to interpret it. And so we can say that the probability that 176 or less of the 200 individuals interviewed will use the Chrome browser is about 0.8212 or 82.1%. The exact binomial probability, if you calculate it, is 0.8195. So relatively close to this 0.8212. All right, so with this, we complete the module 6, and then if you go into Wiley Plus, you will see that there are 5 parts to the assignment, 1 for each section of the chapter in 6 that we call module 6. All right, and this is due on the weekend, Sunday by midnight. So please see the calendar on Wiley Plus to verify when these assignments are due. All right, at this point, you should be able to explain what a continuous probability distribution is and what its characteristics are, and the type of probabilities that can be obtained from my continuous random variable. Also, you should be able to explain the characteristics of a normal and a standard normal distribution. Should be able to transform values from some random variable into a z-score. Then you should be able to use table 4 to find normal probabilities, or I should say standard normal probabilities. And then you should be able to find the value of a normal random variable from a given probability. And finally, you should be able to explain when it is possible to approximate a binomial probability distribution with a normal probability distribution. And finally, you should be able to use the normal distribution to find approximate binomial probabilities. All right, so we're done with module 6.